PFAS chain length could change water treatment design. Today, PFAS management is getting more complicated, and a new review from Hanyang University points to one reason why. Not all forever chemicals behave the same once they enter water systems. The review, led by Professor Ilhan E. Kwan and published in NPJ Clean Water, examines how the length of a PFAS molecule's fluorinated carbon chain can influence where these chemicals move, how they build up, and how well treatment systems remove them. That distinction matters for utilities, regulators, and remediation teams. PFAS are often grouped together because they are persistent and difficult to break down. But the research highlights a more practical reality for water management. Molecular structure can affect risk, mobility, and treatment performance. Long-chain PFAS tend to attach more strongly to sediments, organic matter, and biological tissue. That can increase their potential to accumulate in the environment and in living organisms. At the same time, those stronger interactions can make some long-chain compounds easier to capture using established technologies such as activated carbon adsorption or ion exchange. Short-chain PFAS create a different problem. They are generally more soluble, which means they can travel farther through rivers, groundwater, and drinking water networks. That added mobility can make them harder to contain and more difficult to remove, especially where systems were originally designed around better-known long-chain compounds. What this means for utilities, regulators, and remediation strategies. The findings point toward a more targeted approach to PFAS control. Instead of treating PFAS as one broad category, water operators may need to look more closely at specific compounds present and how their chain length affects treatment options. The review covers evidence from environmental studies, laboratory research and modeling, including work on activated carbon, ion exchange, membrane filtration, and destructive treatment methods. Across those areas, the message is consistent. Treatment performance depends on more than whether PFAS are present. It also depends on which PFAS are present. This is becoming more important as short-chain PFAS are used as replacements for legacy long-chain chemicals that face tighter regulation. While these newer or replacement compounds may behave differently, they are not automatically easier to manage in water systems. For B2B water stakeholders, the takeaway is practical. Monitoring plans, pilot studies, and treatment investments may need to account for chain length differences from the start. A system that performs well against one group of PFAS may not deliver the same results against another. Chain length will not solve every PFAS challenge. Local water chemistry, contaminant mixtures, flow conditions, and system design still shape outcomes, but it gives utilities and technology providers a clearer way to understand why some PFAS move farther, resist capture, and require more advanced treatment planning.